Hello and welcome to this training video. This video is an overview of a teacher lesson for Sketchbox by Slipstream, a building energy modeling software. This is lesson 1, Introduction to Building Models. Many of the slides in this presentation are meant to be used with students. You should have access to all of these slides, customize them, and adapt them for use with your class. This work is supported by Xcel Energy, the Wisconsin K-12 Energy Education Program, or KEEP, Slipstream, who develops and maintains Sketchbox, and the Create Energy Center. To begin, energy is used in buildings, and buildings use actually a lot of energy. Buildings use energy for heating, cooling, ventilation, and for many other uses. In 2021, the U.S. Energy Information Administration reported that buildings use 39% of all energy in the U.S. I think this alone can be motivating for students to understand why this might be important, both from a resource utilization standpoint and also from a cost perspective. Building modeling helps us inform strategies that we can use to save energy in buildings. Examples of this might include upgrading lighting, changing scheduling and set points, update mechanical systems, improve the building envelope. All of these are possible changes you can make to a building, and building modeling helps us understand how impactful and significant those changes can be. This lesson focuses on building size, window fraction, the amount of the walls of the building that are actually windows, and the location of the building, what city and state. The objectives of this first lesson are that students can describe the scale of the amount of energy that's used in buildings. Students can use Sketchbox to model buildings, especially buildings that have a specific characteristic, and that students can list several factors that affect the way that buildings use energy. This slide gives a number of important terms. I won't go through all of them right here, but use this with your students if you wish. These are terms that they'll encounter as they navigate through the parts of Sketchbox that they'll use for this particular lesson. Along with the vocabulary terms on the previous page, here are some important measurement units that students will also encounter during their work with Sketchbox. And again, you can add to this slide or modify it or leave it out if that's appropriate for your context. Using Sketchbox depends on 6 different tool tabs: the Project, Design, Schedules, Baseline, Measures, and Results tab. Each of those tabs has preloaded sample data that allows for students to very quickly model the energy that's used by a building, but also to change those parameters. The 6 tabs that you see here are the key navigating points. This particular lesson actually focuses on 3 of them: the Project, Design, and Results tab. Here's a screenshot of the Project tab. You can see some of the settings that are available here. There's an option to rename a project. You can see the city and state are located here along with the energy code. Also information about the cost of electricity and natural gas and the emissions characteristics of using electricity and natural gas in that location. Here we have a screenshot from the Design tab. Here you can see that students are able to change things like, for example, the area of the building, the number of floors, the height of each floor, things like the wall type, the window to wall ratio, and other physical characteristics of the building. This first lesson also focuses on the Results tab. This is a screenshot from the Results tab that shows the annual energy cost to provide energy for a building over the course of a year. You can see the bar chart is color-coded to indicate different categories of energy utilization within the building, and just by hovering over part of that bar chart, you can see the call-out that's there actually for heating, annual heating cost for this particular building, a little over $5,000. The Results tab also has a number of other charts. Here is a monthly breakdown chart. Again, the call-out feature is available to look month by month at specific categories of energy utilization. And there's also an annual summary table at the bottom. This particular table I've found to be really helpful to cut and paste into a shared spreadsheet so that student groups can try different things to a building, different modifications to a building, and then share those results quickly with their classmates. Here is an introductory case study. In this first lesson, we'll study a 150,000 square foot school building in Chicago, Illinois. And the lesson itself starts by navigating students to the Project tab to set just a few of those parameters. In this first lesson, we will change building size. We'll cut the size of the building in half. We'll change the original building to have more windows, more window area, and we'll move the original building from Chicago to Los Angeles, California. We'll also remind students to make only one change at a time to make sure that they're really understanding the impact of each of those changes to the building and not a cumulative effect of all of them. When students first use Sketchbox, they'll need to create an account. They'll set up an email and password for that account. The website, the web link that you can use for that is here. Hopefully you found that in other materials as well. The login page that they'll see will look like the page that's here, and they just log in with their email and password. I'm going to pause this video just for a moment now and switch over to Sketchbox so I can actually demonstrate some of the changes that students will be making in this first lesson. Right now you'll see on the screen a screen capture of Sketchbox. This is the Project tab. We can see it on the upper left-hand side. This project has not been named yet. We could do that right here. Notice also that this project is currently based in Chicago, Illinois. And we even have an energy code and a number of other parameters specified. We also see the cost of electricity and natural gas and the CO2 equivalents in that location. So the first thing that students will do when they're working Sketchbox to work through this first lesson is to switch over to the Design tab. So right now we're looking at a medium-sized office building that doesn't match the sample building that we were going to model. We'll make our first change by switching here from a medium office building to a school or university building. And we see now that we have what's typically a large middle school or small high school, about 150,000 square feet of area, 2 floors. We're still located in Chicago, Illinois, even though we can't see that from this tab. And we see some other building characteristics for this building. We're going to leave all of those defaults alone and actually just switch over to the Results tab to see what that modeling looks like. So the model ran pretty quickly. Sometimes when you start using Sketchbox, the first model that you run may take a little bit longer. If you're going to demonstrate this for a class, it's not a bad idea to run a model or two before class to make sure that Sketchbox is up and running and the interface is working quickly. What you see right here is a similar table to one that we saw earlier in the presentation. This is the annual energy cost for this building. Again, I can hover over each of the sections of this bar chart to get a call out that tells me exactly how much cost in a year it would take to supply energy for that particular purpose to that building. And so, for example, just the cooling expenditures are a little over $15,000 for this school in Chicago, Illinois. If I scroll a little bit further down this tab, we'll see also the monthly energy cost, and again with really itemized categories based on the categories we see over here to the right, callouts by hovering over particular sections of the bar charts, and at the bottom the summary table that I demonstrated before. So let's navigate back to the Design tab, and we'll make the first change that students make. We'll actually just take the size of this building. This was our baseline data that students would record in their handout, and we'll just change this now to 75,000 square feet. So the building is smaller. We would navigate back to the results and see what we find. Here we'll notice it takes a little bit for Sketchbox to run. I'll make a few comments while that's happening. We've reduced the size of the building, so we anticipate that perhaps the energy utilization now is going to be less. I think it'll be nice for us. We'll go back and compare the cooling expenditure to see as a dollar amount what that turns out to be. And we'll see how that compares for this building that's now only half the size that the building was before. Okay, I paused the video for just a little bit over a minute. It did take a little while for Sketchbox to run. We're back here with results. This, remember, is our building that has 75,000 square feet instead of 150,000 square feet. As we expected, the energy for cooling is quite a bit less, but actually not quite half. And so we'll explore that a little bit more later. But just notice that as we expected, we have quite a bit less energy utilization, and we could compare other numbers throughout the rest of the data that we see here. So we'll jump back to the Design tab, and now we'll change this back to the baseline building that we started with. That baseline building is 150,000 square feet, and if we went back to the Results tab, we should see identically what we had at the very beginning. But now we'll make our second change. The second change is actually to change the window area of the building. And the way that would be done would be to change the window-to-wall ratio on walls facing really any of the 4 directions. In this first lesson, we actually just have students change all of them. And we just make a very simple change. We just double the window area for the entire building. So we would change this window-to-wall percent from 22 to 44 for every direction. I won't change all of them right now. And then run the results again, and students will record just a little bit of that data for comparison. That's the second change that students make, or the second change that students make from the baseline. Now we'll actually go ahead and change that back. So we're still back to our baseline building now. The window to wall ratio is what it's been all along. The area is still 150,000 square feet, but now we'll go back to the project tab and we'll change the location. And so I'll change the state first to California. I get an error because I haven't selected a city yet, but then let's select Los Angeles, California. Actually, you see in the drop-down menu quite a few choices spread throughout the state of California. That's important because Sketchbox is going to use weather data that's available closest to the city that we choose. So now our building's located in Los Angeles. We would navigate one more time to the Results tab. Students would have a chance to record some key data to, again, make comparisons with the baseline case to see how does location affect the energy demands and performance of this building. I'll pause the video one more time and switch back to our presentation to conclude this training video. Having had a chance to see how the lesson functions in Sketchbox, let me offer just a few teaching tips as we close out this training video. This is a screenshot actually that's from the student handouts. You'll notice that there's a blank here for the annual energy costs. This is actually one of the first blanks that students fill in their student handouts. And I put that here actually as a check so that you can make sure that students have selected the right type of building, the right area. You can run this model yourself, post a value somewhere in the classroom for students to compare to so that they know that they're modeling the building appropriately. If the energy cost that they model matches what you have, then you know that they should be at least on the right track. It's important to notice that these values will change slightly over time because weather data will be updated and Sketchbox itself will be improved and have minor modifications. So the values are not static, so it's important each time that you teach the course just to double check which value you want your students to check with. And as they begin the lesson, they can really just check 1 or 2 values to make sure that they're on the right track. Here's a student data table, and so students will fill in annual electric consumption, annual natural gas consumption, annual energy cost for the 4 different cases that we just looked at earlier when we were modeling with Sketchbox. So the baseline case, the case where we changed to 75,000 square feet instead of 150,000 square feet, and the case where we're changing window to wall ratio and also moving to Los Angeles, California. Notice that the table actually does not tell students specifically what they'll be changing in each row of the table. That's actually for them to fill in as they follow through the step-by-step instructions. So here is a summary table of what we find for Lesson 1. If students were to go through all of the exercises that are described in the student handouts, these are typical values for what they might come up with. And so, as we expected, the building uses less energy when it is smaller, and we have additional impacts to discuss by changing window area and the move to Los Angeles. And so this slide is just provided for you for discussion if you wish to use it with your students. Again, the values will change slightly over time, but the general trends shouldn't change. And so you should be able to continue to use these for general discussion after your students have worked through the lesson themselves. Here is a little bit more detailed analysis. Notice that if we cut the area in half, that the natural gas, electricity, and total cost are cut almost in half, but not exactly in half. it's not a bad idea to talk a little bit about why that is and to talk about how the surface area of the building matters, for example. It's also not bad just to have students try to capture in simple terms why is it that a smaller building uses less energy. The second part was where we switched to a different wall-to-window ratio. Notice that having more window area causes us to use more electricity and more natural gas and to incur a higher cost. And so it would be interesting for students to think a little bit about why it is that that happens and if there might be any offsetting factors. I know for my own students, there's often a good debate when they make predictions about this, whether the increased window area will require less lighting for electricity, but how that energy will actually be offset or perhaps even overcome by the fact that it might take more energy to heat or cool a building that has more window area. So good discussions to have there. And the third point was what happens when we move the building to Los Angeles, California. Notice in this case the electricity really stays about the same, but the natural gas use decreases dramatically, but the total energy cost increases. So a lot of interesting discussion points here and a few sample discussion questions that you could use listed here on this slide. If you wish to do a little bit of an extension and start to talk about carbon equivalents already, in Chicago, electricity has a carbon impact of 0.371 kilograms per CO2 equivalent. In California, that number is very different because of different means of generating electricity. Burning natural gas should be the same in either location, but this would be an additional point where you could do some calculations with students. We all know how much electricity and natural gas the building uses. We can calculate what the carbon impact will be. And here actually are some summary results, just again based on the different amounts of fuels that are used and the ways in which electricity and natural gas are produced. Some optional extensions. Students could select an additional city of their choice. Instead of Chicago and Los Angeles, you could compare across the class. They could reduce the window percentage on the north wall, but increase the window percentage on the south wall, for example, and start to examine the directionality of that, how the orientation, the spatial orientation of the building matters. Or students could change another parameter of their interest. And so we have additional lessons already that will work students through energy codes, schedules, measure sets, set points, carbon emissions, and building shape. And so students could start to explore some of those already or explore other conditions that they're interested in. It's really worth noting that the results tab, we looked at just energy cost, but every one of those top two display tables can actually show all 6 of these parameters: energy cost, carbon dioxide, electricity, natural gas, site energy, source energy. So there are many different options. Students could really just start to explore the other display options and see what trends and patterns they notice there. Finally, there are many tutorial videos for using Sketchbox provided by Slipstream that you could use yourself or that you could even use with your students. There is a Welcome to Sketchbox tutorial. There are also specific tutorials for the Project, Design, and Results tabs, and you should be able to access those links either from the Slipstream Sketchbox YouTube channel or by navigating directly to the links that are in the teacher version of these slides. That's the end of our training video for Sketchbox Lesson 1. Thank you for watching. Please reach out with any questions.